Hey everyone, welcome to our lesson on mobile app development. Today, we're exploring key concepts from a set of slides that break down the essentials of building apps for Android and iOS. Let's get started with an introduction from the programming professor, setting the stage for an exciting journey into the world of mobile apps. Mobile application development for Android. Our outline lays out the roadmap for today's video. We'll cover mobile app development basics, dive into Android platforms and how apps are constructed, explore Android Studio and APKs, and see how emulators help test apps. We'll wrap up with a summary to tie it all together. This structure will guide us through the key steps of creating powerful mobile apps, so stick around for the full scoop. Mobile devices have come a long way since the 1970s, when personal computers first became affordable. Today, we've got everything from bulky desktops to sleek smartwatches. Smartphones, tablets, and wearables dominate our daily lives, with users spending more time on mobile devices than desktops for tasks like connecting and computing, according to Smart Insights. It's amazing how these pocket-sized powerhouses have transformed our world. Mobile operating systems are the backbone of these devices, managing hardware and software interactions. iOS, controlled by Apple, offers a uniform user interface, but is limited to Apple products only. Android, on the other hand, is customizable, with UIs varying by manufacturer. In July 2024, Android led iOS in US market share and dominated globally. Your choice of OS shapes your app's design and how far it can reach. App stores are where the magic happens for app distribution. The Google Play Store serves Android devices, offering free apps like Hill Climb Racing, which includes ads and in-app purchases, and paid apps ranging from 99 cents to hundreds of dollars, with a roughly 30% commission. The Apple App Store powers iOS, with similar free and paid app models and a strict review process to ensure a consistent UI. Both require apps to meet specific guidelines for approval. Mobile apps come in three flavors: native, web, and hybrid. Native apps, built with Kotlin or Java for Android and Swift for iOS, deliver top performance. Web apps using HTML, CSS, and JavaScript run in browsers for easy portability. Hybrid apps blend native and web tech for a balanced approach. The slide shows a simple Android native app code that sets up a single screen, highlighting how native apps shine in speed while web apps win in flexibility. Android platforms have evolved since the first release in 2008. Each platform has a version number, like 15, a fun code name like Vanilla Ice Cream, and an API level such as 35. For example, Android 14, codenamed Upside Down Cake, brought better battery life and gesture support. These API levels are key, unlocking new features to make your apps more powerful and engaging. Building an Android app starts with Android Studio, the go-to IDE supporting Kotlin or Java. The compilation process transforms your code into bytecode, then decks bytecode via the R8 compiler, and finally into optimized .oat files for the Android runtime to execute. To test, you use an Android virtual device in an emulator, build and install an APK with the Run button, and see your app's icon pop up on the emulator's home screen. Android apps are built around 4 core components. Activities create single screens with user interfaces, handling interactions like clicks. Services run tasks in the background, like music playback, without a UI. Broadcast receivers catch system or app messages, like low battery alerts. Content providers manage and share data, like contacts, between apps, making your app versatile and connected. Android Studio is the heart of Android app development, producing APKs, the installable files for your app. The process is straightforward. Write your code, build it into an APK, and install it on a device or emulator. Gradle automates the build process, streamlining everything. Android Studio makes creating and deploying apps efficient and developer-friendly. The Android project structure is like a well-organized toolbox. The AndroidManifest.xml file defines the app's name, theme, and permissions, like camera access. The Kotlin plus Java folder holds your source code, like mainactivity.kt, which runs the app's first screen. The res folder stores resources like images and UI strings. Gradle scripts, including project and app-level build.gradle.kts files, handle build configurations, while libs.versions.toml tracks library versions. Emulators let you test apps on virtual Android devices, like a Pixel 2 with API 34. You set them up in Android Studio's Device Manager, create a virtual device, and launch it to run your app. Extended controls simulate real-world scenarios, like changing location or mimicking calls, making emulators a must-have for catching bugs before release. To wrap up, we've seen how mobile devices have evolved from clunky PCs to powerful smartphones. Android and iOS offer distinct ecosystems, with Android excelling in flexibility. You can build native, web, or hybrid apps to suit your needs, leverage evolving Android platforms for new features, and use Android Studio to create and test APKs on emulators. Now you're ready to start crafting your own amazing apps. What's your next big idea? Thanks for watching. Let me know in the comments if there are other topics you would like me to talk about. If you enjoyed this video, please like, share, and subscribe for more content on software engineering and technology. See you next time.